Hello everyone, welcome to my YouTube channel. I am Muhammad Talha and today we are going to start a brand new series of Numpy in Python. In this video we will learn that how we can install Numpy inside of our laptops and how we can integrate it with our Visual Studio Code. We will also work with Google Colab just to have multiple options, and we will also learn that what is common and what is the difference between Python lists and Numpy arrays. So without further ado, let's just dive into this video. So here we are at my laptop's screen, and first of all we will learn that what is Numpy. So it is a library for Python programming language which is mainly used for mathematical operations on arrays and matrices. It provides us support to solve simple and complex mathematical problems, and it also supplies an enormous library of high-level mathematical functions that operate on arrays and matrices. Right, so first of all we will just go ahead and try to install this library inside of our laptop so we can move ahead and perform certain operations and tasks using this library in Python programming. For that, what we will do, we can just go ahead and open up our git bash terminal. If you don't know what is git bash, I have a complete video about it and how to install it inside of your laptop. I will mention the link of that video in the description section of this video, so you can also go ahead and check that video as well. So to install Numpy, what you have to do is just go to the root directory of your computer. For example, what I mean to say is we can just go ahead and write cd desktop, and this will take us into the desktop directory of my computer. But you don't have to be here. You have to be in your root directory. So for that, if you are not in your root directory, you can just go ahead and type out this command until you reach at this point where you have this curly symbol. And this means that you are in your root directory, and here you can install anything that you want. And after that, you can just go ahead and write a command pip install numpy, and it will install this library inside of your computer and laptop. And as I have already installed it inside of my laptop, so it is giving me this notification that a requirement already satisfied, but in your case it will actually go ahead and install it. So I'll just go ahead and clear this terminal here, and after that I will open up my Python IDLE. So we can interact with this Numpy, or we can just open up a Visual Studio Code. So this is a Visual Studio Code. I'll just go ahead and clear this terminal out, and here you can see we have the same terminal, right? You can see this is almost same as this right here, which means we have integrated our git bash inside of a VS Code. So I also have made a video about it too, so you can go to my channel and check that video as well. But right now our main focus is interacting with Numpy. So as I told you that this is a library for Python programming language, and just like any other library you have to import it, right? So for that you can write import, and after that name of the library, which in this case is Numpy, and after that we'll give it an alias np. So now we don't have to write Numpy in our entire code. We can just call it by using np. Okay, so simple as that. So let's just go ahead and take a variable a, and in that variable we can create an array, and in that array we can create we can pass an object of list here. So this is the array that you want to create, but we want to create it using a Numpy array. And after that, what you can do is you can just go ahead and print your Numpy array. So you can save this program, and after that you can just we'll say execute this program, and as soon as you hit enter, you can see here you have your Numpy array. Okay, so this is the shortest way that you can create an array using NumPy library, but we have multiple other options as well. Let's just go ahead and see how many other functions that we can use to make NumPy arrays. So how to create NumPy arrays? We have multiple functions that can be used to create NumPy arrays using Python. We have a function like array, like we just used earlier. We have arrange, we have linspace, we have random, ones and zeros. And all these functions can be used to create NumPy arrays, and those arrays can be of different types, but at the end of the day, those will be arrays, right? So let's just go ahead and discuss that what is the difference between lists and NumPy arrays. Why do we have to create NumPy arrays? Why can't we just go ahead and utilize Python lists to perform our tasks? So first of all, we will discuss the common things that we have in both of these data structures. We can use NumPy array or lists to store data. Obviously, we can store our data inside of it, whether it is a number or it is a character in case of lists. But all that data can be stored inside of your lists and as well as inside of your NumPy array. Now, just like a list, NumPy array is also mutable. So that means you can change it, you can delete items from it, you can add items in it. And just like lists, you can index NumPy arrays. For example, here we have a list and NumPy array called A. And in that A, we have multiple items, which are 1, 4, 6, 7, and 8. Now all these items have specific indexes stored against them. So this is common between both data structures. We have those indexes in NumPy arrays, and we also have those indexes inside of our Python lists. Because of those indexes, we can also go ahead and do slicing. So we can slice our NumPy arrays, and we can also slice our Python lists. Now let's just discuss the differences between NumPy arrays and lists. When we talk about Python lists, you can store multiple data types inside of your list. For example, you can create a list which will have numbers in it, characters in it, right? But that is not the case for NumPy array. You can only store numerical values inside of your NumPy array. And the second difference is the lists are built in Python programming, but as far as NumPy is concerned, you have to install this library like we just did previously. And also, operations work differently on both of these data structures. For example, we will just go ahead and try something out. We can open up our Visual Studio Code, and here we had our NumPy array. So in case of a NumPy array, what if I just go ahead and I try b is equal to a divided by 3, and I will just change my list so we can have we can see the results more precisely, right? So we can create 27, and we can create 9, and we can create 3, and I think that should be enough, and I will remove the other part of the array. And after that, we are just dividing that array with 3, and after that we are storing the value inside of our b. And what if I just go ahead and try to print that b? Right, so I'll just save this program, and I will again run this program, and here you can see the values are actually divided by 3. So at the first index we had this 12, but 12 divided by 3 will be 4, right? So here we have this dot here, that means 4.0, right? So it is also giving us the decimal value after dividing the whole array with 3. And at the second index we had this 27, so 27 by 3 we will have 9, and same for the other two values. So this operation can be done with NumPy array, but what if we try this with list? So I'll just comment this out, and I will use a, and I will create a list 1, 2, 3, or we can just use the same items. We can write 3, and after that I will save this program and I will again run this program. And here you can see this time you got traceback error inside of your answer as you did with the NumPy arrays. So operations work differently with NumPy arrays and Python lists. So we will discuss NumPy array operations in details in future lectures, but for now we will just discuss the advantages of NumPy array over lists. So NumPy arrays actually take a very less memory, and they are way faster than Python lists, and they are more convenient to use for mathematical operations. You just saw earlier that I took the entire array and I divided that with 3, and all the results were divided by 3 without using any for loop or something like that, right? So they are more convenient to perform different mathematical operations. So I think that is it for this video. Now if you like this video, if you learned something significant, I highly encourage you to like this video and share it with your friends, and also don't forget to subscribe my YouTube channel and click on that bell icon so you get the notification whenever I upload some videos like this. So goodbye for now.